I'm very glad to be here, and I really appreciate the call from the Carpenters Company to make this presentation today. I did not do this alone. No project is done alone. I don't have to tell anybody in this audience that the Statue of Liberty restoration in the mid-'80s was accomplished by a huge team. The National Park Service, and I was the project architect on behalf of the National Park Service, teamed with the Statue of Liberty Ellis Island Foundation, which is Park Service, and the Statue of Liberty Ellis Island Foundation still exists today. And the Statue of Liberty, for those of you on the construction side of preservation, the Statue of Liberty Ellis Island Foundation purchased and owned the actual restoration work, which was then donated to the National Park Service. So for a period, the statue was, in a sense, turned over to the foundation. The foundation was actually established to fund and execute the 100th anniversary celebration in 1986. There was a prior foundation, which was a French foundation, which did the initial investigation on the statue that didn't survive its own fundraising efforts. And as a result, the Statue of Liberty Ellis Island at that time, the Statue of Liberty Foundation took over the construction as well as the celebration, and then eventually added Ellis Island to its portfolio as well. So there were a lot of people involved in this project. You'll see a lot of people in the slides that I have. But I want to, these are, unlike a lot of people's presentations, this presentation builds on a lot of old material. I had never had I have no slides that are scanned. So these are old slides and old images scanned for this presentation. So the quality varies, but you won't see a lot of this stuff anyplace else because it's all a product of my own camera. Icon, the word icon is in this in the title of this of my portion of the presentation. I'm doing the then portion of the statue project, and Michael Mills will do the now. I'm the before, and Michael's the today, not the after, because it's not done yet. But the icon question, and I couldn't help but use this slide. This is I had completely forgotten that I had this slide. That standing at the top of the scaffolding that was above the crown, the head of the statue, which is in the bottom of the slide, looking at sunset toward the World Trade Center. So what is an icon? Some things are icons from the very beginning. Some things become icons by, in the case of the World Trade Center, catastrophic events. The Statue of Liberty was an icon from the beginning. There was a presentation, I work at the National Gallery of Art. There was a lecture last week. The lecturer defined icons as loquacious artifacts, an artifact that continues to speak to people today. And the statue is, in fact, a very loquacious artifact, as the World Trade Center has become a loquacious artifact. This is a 2-page spread in the New York Times Magazine, maybe weekend before last. This is a Chinese artist who is, the artist's career as a sculptor is focused completely on the Statue of Liberty. This is the Statue of Liberty as Mao, attempting to address the Chinese people in their idiom, the idiom of Maoism, and to address topics of liberty to the Chinese. So this is contemporary art based on the Statue of Liberty today. The iconic nature, the iconic character of the statue continues. So this is also a master builders program. The statue in the 1870s, 1880s involved 3 master builders, one of whom was the mastermind among the master builders, and that is Auguste Bartholdi, a French sculptor from Alsace. Alsace is one of those areas in Europe that switched countries frequently, but at this time and since is in France. Gustave Eiffel, a very well-known name to all of us, a French engineer, pioneered iron and steel construction. The Statue of Liberty predates the Eiffel Tower, and in fact, the core tower of the statue is in many ways, it's a small Eiffel Tower. And Richard Morris Hunt, the first American architect to complete the Beaux-Arts program in Paris, constructed Newport Mansions, constructed the Metropolitan Museum that we see today, that followed the Calvert Vaux Museum, and through connections in New York was selected to design the pedestal on which the statue was built. Bartholdi had a rough idea, as you'll see, of what the pedestal should look like, and then Richard Morris Hunt made that real. This is Bartholdi in his studio. You see a maquette of the statue on the left. The idea began as a gift to the United States in honor of its centennial in 1876. The project was 10 years late. It was dedicated 125 years ago tomorrow, on October 28th, 1886. But parts of it were here in Philadelphia for the centennial exhibition, as we'll see, in 1876. So in the 1870s, Bartholdi came to New York, came to the United States for the first time in 1871 to tour the United States to see where a monument to liberty could be located. And Bartholdi did his grand tour of the United States from east to west, including the upper Midwest. Chicago, of course, this is 1870s, was a very important mercantile city. And in the end chose New York as the place that he proposed to. This was still a proposal at that time and hadn't been presented to the U.S. government yet. The Statue of Liberty is sort of a redo of what Bartholdi proposed for the entrance to the Suez Canal in the 1860s. This is the maquette for the monument at the Suez Canal. You see many things that are reminiscent. For one thing, all of Bartholdi's figures are right-handed, so the statue is right-handed. The next slide's back to front. You'll see it should be right-handed. You'll see other sculpture in New York. So this is his Suez Canal monument. This was his rendering of what the Suez Canal would be like. Remember those rays coming out of the forehead in this case. Here's the Statue of Liberty. Same rays coming out of the forehead. This is Bartholdi's rendering of the statue in New York. And of course, this is the view. The view of the statue is not from Manhattan. The view of the statue is from the Atlantic. The statue is advancing to the world, liberty enlightening the world. So this is the view that Bartholdi presented to the United States government. Bartholdi, after his first visit in 1871, he was commissioned for several works in Manhattan. One is a Lafayette. This is the base of the Lafayette sculpture that's in Union Square. There's a Lafayette and Washington in Upper Manhattan. And then for the Philadelphia Centennial Exposition, he was commissioned for one of the major fountains, and this is at the U.S. Botanic Garden in Washington today. So these are the three other Bartholdi works in the United States, other than small pieces in museums. This is what Bartholdi saw. It was sort of a tidal island, very small, in the 1870s, that had on it a fort that had been constructed between 1808 and 1811 as part of the fortifications, a little late for the War of 1812. So imagine that you're the US government, you're in fact the War Department, and the president and some of his cabinet members and aides are now telling you that you are going to demolish one of your a large part of one of your fortifications and a fellow from France will come and install a colossal copper statue. So the improbability of the Statue of Liberty in historical imagination it's really quite stunning if you try to imagine this today. So this is the interior of Fort Wood prior to the construction of the statue. So inside of the Star Fort that still exists today was the actual operational fort, and this is the parade ground inside of Fort Wood. The statue began construction outside in Paris. There was a workshop. Gautier was the fabricator for the Statue of Liberty. Parts were created inside and then assembled outside. Here's a view, newspaper view of the interior of the Gautier workshop. The first portion completed was the arm and the torch and the flame, and that visited Philadelphia again in 1876 for the Centennial Exhibition. It was then returned to Paris, slightly adjusted and installed on the statue, which was still under construction in Paris, then disassembled, crated, and shipped to the United States, where it waited for the pedestal to be completed on the island. So here is here's the beginnings, the lower portion of the pedestal. The pedestal is mass concrete, no reinforcing. What you see are the barrels of cement, unused barrels stacked at the fort wall, and then the refuse barrels of cement tossed over the edge. And in order to construct this, you see which was common in large construction projects, you see the small railway that was constructed to transport materials from the dock to the construction site. Pedestal rising. So when it was completed, this is an 1830s photograph. This is a 1930s photograph. This is at the time that the Park Service took over the Statue of Liberty National Monument, which had been declared probably improperly by the War Department in 1915. It's a little shady on why the War Department would have declared the statue a national monument, but it was later confirmed through the Department of the Interior as a national monument. But you see that even when the Park Service took it over, was assigned the site at the time that Roosevelt, FDR, transferred a lot of military sites to the National Park Service in the 30s. It was, at that time, still an active military base. So that the national monument in 1915 was the statue and its pedestal. That was it. And in the 1930s, Roosevelt expanded the national monument designation to the whole island as part of the transfer to the National Park Service. In preparation, the work in the 1980s was not the first major work. Soon after the statue was never intended as a site for public visitation. So there was nothing inside the statue except its own structure when it was completed in 1886. But soon after, 1887, 88, 89, the initial stairway was constructed inside so that people could reach the crown and could reach the balcony around at the upper part of the torch. So that was the initial phase of construction. There really were no visitor facilities because, again, that you were visiting on a military base. So the visitors were sort of shunted right into the statue and took their visit and left. In the 1930s, in preparation for the 50th anniversary of the statue, it's interesting how young it is because, of course, icons, that's part of being an icon is it seems like it's been there forever. So in the 1930s, in 1936, the statue was only 50 years old, and the Park Service undertook the first restoration, really extensive repair of the statue, which was principally focused on repairing particularly deteriorated iron bars which formed the armature which supported the skin. So in the 1930s, selective replacement of the armature was undertaken. A forge was set up on Liberty Island. This almost parallels exactly the work in the 1980s. A forge was established on Liberty Island, and bars were removed, bar on the left, a bar removed from the statue and reproduced in iron again on the right. You see the fort buildings in the background. All of the work in the 1930s this is a significant difference between the 1930s and the 1980s work, is that all of the work in the 1930s was done without scaffolding. You'll see the small scaffolding that was built to protect the visitors, but otherwise the work was done with in bosun's chairs hanging off of the top of the statue. This is removing, without scaffolding, the copper rays, copper and bronze rays from the diadem of the statue, taking them in, down, repairing the iron inside, replacing the iron inside, and reinstalling them again from the inside. Also at this time, the configuration of the stairs was changed. The statue was a very popular site for visitation, and the stairs were changed and the first elevator was installed. That required more space inside the pedestal, so the jackhammering is increasing the opening in the central opening in the pedestal by removing the concrete. And a little more space was required in the 1980s, and the exact same thing was done again. So now we're getting into the 1980s project. So here's the bit of scaffolding that was built to really to protect the visitors on the top of the pedestal and to continue to allow visitation there. But one of the first, and the statue project in the 1980s, it depends on what your own interests are, because there's a bit of something for everybody. If you're a scaffolding enthusiast, this was this was a performance spec for the scaffolding, which was that the scaffolding had to allow the removal of the flame, which determined how tall it had to be. And the scaffolding could not touch it had to allow access to the statue within 12 inches, but it could not touch the statue or anchor in any way to the statue. So above the pedestal itself, to which the statue was sort of pressed against, the scaffolding was pressed against, above the pedestal, the scaffolding is freestanding. And this engineering was done by Universal Builders Supply. In the 1980s, the work that had been done in the 1930s, in large part, many of the failed armature bars were bars that had been replaced in the 1930s because the runoff of water on the interior of the statue hadn't changed. So you had the same deterioration in the same locations as in the 1930s, but of course there were more locations. So this is looking up the arm, and you see how complicated this is. Please also bear in mind that the 1980s project began in the fall of 1983, and Ronald Reagan rededicated the statue on July 4th, 1986. So in that time, all of the armature on the interior of the statue was removed and replaced. The very smallest workers were used, that's the good word, to access the inside of the tablet on the statue, which is only a little 2-foot space, and none of the original armature was left. Every bit of the iron armature was replaced with stainless steel. Again, you see how closely the armature follows the shape of the skin. So in the 1980s, same as in the 1930s, the existing armature bars were removed, and recreated to match in stainless steel. The stainless steel was selected with the assistance of Texas Instruments. This is Bob Baboyan, a metallurgist with Texas Instruments, at the outdoor weathering site, which is probably, it could still be there today, which these are all the choices of materials that were considered for the replacement armature. The final material is ferralium, which was a high nickel content stainless steel produced by Cabot. Again, the replacement armature was produced on site in a workshop that was built on site. Another portion of the project, which was as delicate as recreating the armature piece by piece, was repairing the skin, because of course now you really are dealing with the very fabric of the icon. And over time, this is the bottom of a curl on at the neck of the statue, and water intrusion had eroded the copper that it fell apart. So in about a dozen select positions, the actual skin of the statue was replaced. This is the workshop of P.A. Fiebiger in New York. That's Joe Fiebiger. On the far left of the slide, you see the replacement tip for that curl, which then they sawed off the bottom of the existing curl at a joint line. In investigating how the statue skin was constructed, there are really two kinds of joints. On the general work, which would be sort of the robe, it's all lap joints. It's a simple riveted lap joint. On the more finely sculpted work, it is a planished joint where sawtooth edge meets sawtooth edge. It is the traditional French way of installing the bottom on a pot. And that is exactly how in the more sculptural portions of the statue, the sheets were connected one to the other. And so that is how then the tip of this curl was reinstalled, just like you would install the bottom on a pot. One of the problems on the interior, of course, was water intrusion, and the project was dedicated to doing something about that, not that it could cure all of the problems, but associated with that was the great number of coating layers on the interior of the statue. Sometime in the 1890s, probably, the statue was first coated with coal tar. And subsequent to that, just as part of maintenance in order to keep the statue looking fresh, layer after layer of paint was installed. All the early layers, of course, were lead paint. So we already had an asbestos problem because the original construction used asbestos sheets to insulate the iron bars from the copper skin. That was handled as part of removing and replacing the armature, but the idea of making lots of little particles of lead airborne within an enclosed space was a real, as part of removing the material, was a real abatement problem. So we searched for ways that we would not increase the volume, because we're on an island, that we would not increase the volume of the hazardous waste with whatever medium we would use to blast the paint off of the inside of the skin. So the final choice was liquid nitrogen, because the liquid nitrogen would fracture the coatings within the coal tar layer. So we had half the coal tar layer left at the end of the nitrogen removal treatment, but we had no greater volume than just the paint itself. We didn't have sand, we didn't have rice hulls, we didn't have whatever one might choose. So this was the whole point was to reduce the volume of hazardous materials that had to be handled in the statue, on the island, and transported off the island. So this was the liquid nitrogen treatment. Union Carbide set up a huge liquid nitrogen supply plant on the island in order to supply liquid nitrogen for a process that at this point was going 24/7. There were people up there with wands blasting away with a shower of fractured coating coming down continuously. This was the final effect. This is with the copper skin clean down to copper. The final removal of the coal tar was with solvent. First with pulverized walnut shells, and then with solvent for the final clean. And this is with the clean skin with the new stainless steel armature. Another sort of sensitive portion of the project was the replacement of the flame. In 1886, within months of the statue's dedication in New York Harbor, the statue was turned over. It had to have a bureaucratic home, and it was turned over to the Lighthouse Board, which immediately needed to find a use. It had to be a navigational aid. So the Lighthouse Board began the original flame was constructed the same way as the rest of the statue, continuous copper sheets. The Lighthouse Board began cutting first one row of holes with an electric light on the inside, and then a second row of holes, and then a third row of holes. The statue never qualified. The strength of the light coming out of all of these holes never did qualify the statue as a navigational beacon, and eventually in the 1930s, the flame was turned over to Gutzon Borglum, the sculptor of Mount Rushmore, to come up with a new idea of how the flame could look. And Borglum both cut apart the flame as well as cut into the flame to install colored glass, darker at the bottom, lighter at the top, and new lighting on the interior. And of course, this is the flame that many of us grew up with and was the flame for the Statue of Liberty. For all we knew, that's the way it was done. This was a source of water intrusion, and it was literally falling apart at this point. So either the choice would have been to reproduce the Borglum flame, or to reproduce the original flame. This goes to Mr. Milner's points earlier. And the decision was to recreate the original flame. This is a model that's about 8 inches long. This is a plaster cast from the original clay maquette of a solid skin flame. Working on that, then the contractor, Les Meteliers Champenois, which has an office in Paterson, New Jersey now. They were exclusively from France at that time. They made the neck size version of the flame, they made the neck size version of the flame, and they made the full size version of the flame. And what you see is the stainless steel armature for the new flame, for which there was no existing model, being created against the plaster full-size version of the flame. This work was done in repoussé, which means the copper is hammered on both sides, in a workshop on Liberty Island. Both the flame and the upper portion of the torch, which is in the background, were reproduced. In about 24 to 48 hours, the flame was gilded. The two choices of gilding that were considered by the project were electroplating and gold leafing. Electroplating, there's two types, or so I understand, or so I recall. Two types. One is tank, where you could install it, which did not exist for an object this size. And the other is that you can use a wand, an electric wand, create a charge on the substrate, and with a bottle of gold in solution, you can plate gold slowly but surely onto the surface. It is nearly impossible to do that upside down because you're spraying the gold on. It works very well above, but not from below. The flame, at this point, this was too difficult to turn this thing over. And a father and son team was brought from Paris, and they varnished it one day. That's what you see as sort of the dull matte. That is a tinted varnish. as the base for the gilding, and that sat overnight, and then they gilded it within a day, the father and son working together. There are not a lot of photographs of this because they did it in a tent because of the air movement. Liberty Island's a very windy place, and there are not a lot of good shots, but this gives you a sense of what they were doing. It worked. Here's the new flame sitting next to the old in the workshop in which all of this was done. That actually has snow on it if you looked. New York is quite an aggressive environment, and even in such an aggressive environment, I understand that the gold leaf is holding up very well. There were quick wear tests done, again by Texas Instruments, in order to determine whether electroplating and gold leafing were in any way comparable as far as wearability is concerned. And the gold that the French proposed to use for this, which is hand fabricated, is in fact a particularly dense surface. And the difference, there was obviously a difference between electroplating wearability and the wearability of gilding, but it didn't tip it toward either not doing any gilding, which was also a choice, because it was not 100% clear that it was 100% clear that Bartholdi intended the whole statue to be gilded, and then intended at least part of the statue, the flame, to be gilded, but it was not 100% clear that this was ever completed, but it was done for this project. It is reversible, but no one's chosen to reverse it yet. And that's the flame. This is the then. And I haven't talked much about the stairs and the elevators and safety concerns, because you will find out in a moment that all of that, following 9/11, has been rethought. And the person that's in charge of that rethinking is Michael Mills.
Like John, I'm not in charge of the project, but I am privileged to be the architect and head of a multidisciplinary design team that is working now at the statue. That includes Keystone Hood, Hughes Associates, fire protection consultants, Joseph Loring, engineers, the lighting practice of Philadelphia, and RBA, civil engineers. And I'm sure I'm leaving a lot of other people out. So what has happened since John has completed his work? Well, thankfully, the work that they did is in great shape. The statue itself is really weathering well and wearing well, and all of that stainless steel is still in terrific shape. But what has happened since the 1980s is that millions of visitors, at least 7 million a year, I believe, is the current figure, and it's probably going to increase. So under that kind of onslaught, the finishes wear out, materials change and wear. The mechanical equipment in the statue is nearing the end of its life. There are new code requirements for accessibility and egress, and of course, 9/11 happened. And since that, various things happen. New sensibilities about public safety and what can happen in an event like that. And actually, the crown access was closed at 9/11 and after 9/11 and never reopened. The pedestal access was also closed, but was reopened a few years later. Let's see, how do you go forward? Here we go. So our project goals of the current project, and I'll be very brief and try to focus just on the main elements of the design to try to keep on schedule. But they are to basically improve life safety and code compliance, preserve historic fabric while doing that, improve the visitor experience, and improve accessibility, and make a more efficient and maintainable structure. The monument terminology, there are 9 levels in the statue itself, and there's 7 levels in the pedestal. Most of our current work is in fact, all of our current work is in the pedestal, except for some mechanical equipment for the statue itself. The pedestal is a granite-faced concrete structure. It sits in the middle, whoops. It sits in the middle of Fort Wood. And the top of Fort Wood, that level is called the terraplane, and that's a public access point. It also has modern construction here called the AMI space, which was the American Museum of Immigration, which was on Liberty Island before it expanded and went to Ellis Island. And those spaces were built in the 60s, I believe. The first phase of our project was actually in 2009 and completed then. We served as the Park Service's advisor for quality assurance for the reopening the Crown, which happened on July 4th of 2009. It was a design-build project. Calamex was the contractor with Kramer and Marx Architects of Philadelphia. Actually, I think their office is in Ambler. And they worked with Calamex to design the handrails, which it involves adding new code height handrails to give a better feeling of enclosure as you come up the double helix stair. Also, there were glass panels added at the landings to also give one a greater sense of enclosure. That project was started in April of 2009 and finished by July 4th, design through construction. These are some photographs of the interior of the pedestal prior to John's project, showing some of the constraints. The Eiffel beams, which are essentially tie-downs. These bear on the concrete walls, and they have straps and rods that basically tie the statue down to keep it from toppling in heavy winds. You see some of the structure that was there, I think, prior to your project, John, that was renovated in the 1980s. Here are some drawings of the physical constraints. There is what we call the pinch point, which is down at the lower end of the statue. This opening is 27 feet square, which is how the stairs go up to the observation deck. The pinch point down at the base reduces that even further to 17 feet square. So there's really only room for one stair and the elevator to go to the lowest reaches of the pedestal. We did this drawing to show it's an overlay showing the pinch point here and the location of the Eiffel beams here and here to show where the possibilities were to put an elevator. There were only 4 that would go from the bottom all the way to the top. Here are images of the existing installation. This elevator in the middle of the pedestal is the largest hydraulic elevator in the world that was put in there as part of was that in the 80s or was that in the earlier? That was in the 80s. It's a 2-story, it's a double height elevator. Unfortunately, that's one element that didn't work too well from the outset. And increasingly over the years, it's been harder and harder for the Park Service to maintain it, to the point when quite a lot of the time it's out of service. There was also an emergency elevator that goes up through the statue, up to the shoulder. It's basically a sort of a glass coffin that you can stand up a stretcher with a person on it and bring them down to the base of the statue should somebody have a medical event while up in the statue. and that was a very important feature. There are these sort of cattle chute stairs, open stairways with metal sides with fairly low handrails. So the major components of this project are summarized on this slide. It's to replace the main elevator. One of the reasons for that is to get rid of the hydraulic fluid, getting rid of any combustibles in the statue, providing 2 enclosed fire stairs, which is quite a challenge to do 2 711 stairs in this space and have them completely enclosed from each other. To provide smoke separation between the statue and the pedestal, to replace all the HVAC equipment to improve comfort, and also to provide adequate access from the terraplane to the ground at the north and the south. And I think all those elements are shown there. Because the project was so challenging, we decided we had to model it from the outset 3-dimensionally. The 27-foot space crisscrossed by the Eiffel structure that we weren't allowed to touch created a 3D puzzle. We actually were able to present the Park Service with 3 stair design options from which to choose, and that was dependent on which location for the elevator that we chose. This image shows the accepted stair design. Stair A is the up stair, which goes from 1P, which is at the lowest level of the pedestal, up to 6P, which is the observation level. And then the down stair is from 6P to 3P, because we can't get 2 stairs down to the very base of the statue. And 3P connects by exterior stairs to the terraplane level and then gets you out of the monument in that way. From a design standpoint, we tried to keep stair A as open as possible because the cattle chute stairs were very open and you could actually touch the Eiffel structure. And we wanted the public to continue to have and the Park Service wanted the public to continue to have the experience of exploring the statue from the ground, seeing the Eiffel steel up close and so forth. Stair B is enclosed in metal-covered precast panels, it will be, it's not built yet, which presents a durable, low-maintenance, graffiti-resistant surface that can be easily repaired if it's damaged. We used some fire-rated glass at a couple of key locations to kind of break down the tube-like structure of stair B. The elevator will be totally enclosed in a 2-hour poured concrete shaft. Stair A is enclosed within the concrete pedestal down low, although it's open for much of its height in the middle of the pedestal. And it's an enclosed fire stair by virtue of the fact that everything else in the pedestal is separated from it. And then the stair A itself is enclosed by the original concrete of the pedestal. Thank you. We were also charged to design 2 means of egress off of the terraplane to provide full code compliance for the possible hundreds of visitors that could congregate there. To minimize the intrusions or potential intrusions to Fort Wood, our proposal was to connect one of the exits to the main entrance so that you wouldn't have to create a new opening through Fort Wood. And the other would be connected to an existing sally port on the opposite side of the monument. And that's what this drawing is showing. We also needed to provide elevator continuity from the lowest level up to the observation level, and also to the emergency elevator, which extends up to the shoulder. So we're using a machine roomless elevator installation. It's an MRLI, which stops at 5P because the equipment is on the top. And also we have to have a fire separation at the ceiling of 5P. So then we have a one-stop lift from 5P up to 6P so that wheelchairs can get to the observation level for the first time. The existing elevator, I should have said, only goes to 5P. So really, one can't get up to the observation level unless one's carried from 5P up to 6P if you're in a wheelchair. The next series describes our terraplane egress solutions. This image shows the temporary wood egress stairs that currently exist over the Fort Wood walls. They were supposed to be there for 2 to 5 years, and they've been there quite a bit longer than that, I'm sure, at least 10. The New York State Preservation Office is very anxious to get rid of those wooden stairs. Our proposal is to excavate into one point of the star of the Fort Wood wall and create a new masonry stair within the fort, exiting to the main entrance. And again, that's to keep from creating another opening. There's a big concern in doing this about potential archaeology. But in this historic view of the statue from the 60s, when the AMI was built, you can see that they excavated completely into that area. There's another view of the same location at the same period. You can see the arches that support the terraplane of Fort Wood, sort of the parade, well, not the parade ground, but the upper observation level, and everything behind that wall was taken out in the 60s to build the AMI. So here's a 3D drawing of our proposed, about to be built, new egress stair from the terraplane on the south side of the monument. This is an existing stair coming off of the pedestal. I'll show you some more of that in a minute, to get to the terraplane, and then all of this would be new. So the idea is that the egress route would be down this stair, down against the wall, along the wall, and then out beyond the existing front entrance to the monument. On the south, we proposed a new exterior stair directly linking to stair B that would match an existing monumental stair on the north side. So these are going to be new granite stairs to match what already exists. And then there'll be an interior stair from the terraplane going through those doors, down a stair, and then it'll link up to the sally port, which is a historic feature that actually used to be the main entrance to the monument back in the early 20th century. And that's going to become the new exit point for visitors. So this is a historic view of the construction of the existing monumental stair to the north in the 1960s. And this is what that looks like today. And that's a part of what I've been calling the AMI space. Here's an existing view along the south wall of the AMI space showing where the new stair is going to go. And this schematic shows how the new granite face stairs will be added and how they relate to the monument and to the pedestal walls. It's interesting. At one of the early meetings, the first thing I proposed to the Park Service was that maybe we should look at removing the AMI. Because it's kind of an intrusion, you know. I mean, it's granite and everything, and they tried to do a good job with it, but it's sort of these concentric donut rings at the base of the statue that had nothing to do with the hunt work or Fort Wood. And they just said, yeah, you know, that's not in the budget and so forth. And I backed off. And I'm glad that we never had another discussion of it, because the AMI space, which is actually an empty museum space, is a loft space now, totally empty. We are filling it with mechanical equipment and emergency generators and the thing is, it's going to be packed. And I don't know where we would have put all that stuff. I actually didn't know we were going to have that much stuff at the outset, and it just got more and more and more. So all the workings, all the safety systems, all the stair pressurization, the smoke evacuation is all going to be accommodated in that AMI space, which is a great use for that structure. So now I'm looking at the AMI space a lot differently than I did at the beginning, thinking, oh, it's not so bad. And again, we looked at historic views because we were talking about excavation to go to the Sally Port. The Sally Port is up in this area, and you can see that, again, they removed all of the soil, most of the cultural material. We are going to have monitoring going on during this project, but we had a feeling that we weren't going to be disturbing a cultural material by doing what we're proposing. The Sally Port Tunnel will remain as a historic feature and will serve as the egress point from the monument. And this axon from the height of the terraplane shows how those new stairs will bring one down to the terraplane level. It's interesting that during the building of the AMI space, the Park Service provided temporary access to the statue, and it was maintained on the Sally Port side of the monument. You can see visitors lining up here, and then going up this wooden stair on the steel bridge, basically over top of the excavation. It's hard to imagine that happening today on a construction site. But so after the design was presented and reviewed at various stages, value engineered through the Park Service's choosing by advantages process, and finally approved, we began construction documents for the project. And there was never any question that we were going to design this project in 3 dimensions in Revit. The tight tolerances, the structural requirements of the new features, the meeting up of the levels, the coordination of all the systems, such as electrical and lighting, sprinklers, HVAC, telecom, and security. It requires an amazing amount of coordination to fit into a space like this, while of course preserving the National Historic Landmark design and the materials which we're not allowed to touch by the National Park Service. So this 3-dimensional puzzle could only be solved by designing it in 3 dimensions. And it allows us to enlarge details at any point within this drawing, and to study potential conflicts and clearances, and also actually take a walk up and down the stairs to see what the visitor experience might be like. The students at the University of Texas had undertaken laser scanning of the interior of the pedestal as part of a Historic American Engineering Record documentation project. We utilized those scans, established new control points, and then did additional scanning to create these drawings. That was stair A that I was showing you. Here's stair B coming down from 6P on the back side of the monument, and it exits down here at 3P. In an emergency, both stairs become downstairs. So, they're both utilized for egress. The next series is sort of a CAT scan through the pedestal by level. And I'll run through this real fast. 1P is the lowest level where the stair begins. 2 existing tunnel accesses to the museum were kept, here and here. And 1 to be used, which used to be the elevator machine room, was reopened, so there's actually improvement there. The 4th is closed off by the elevator, and that becomes a larger first aid room than exists now. 2P is the level of the pinch point. There's 1 existing egress to the north, which is kept, and the rest is surrounded by 8 feet of concrete. At 3P, stair A emerges from its enclosure on one side of the elevator and becomes an open stair with handrails. The enclosed stair B ends at this level. So that's B ending, and that's the egress from there. And here's stair A, and this is starting up into a large area above this that's basically almost a loft space. At 4P, things get very interesting because both stairs have to turn 90 degrees and pass each other to get through and above the existing Eiffel girders without touching them. So the green designations are the built-up Eiffel girders going in each direction. And you can see the stair A is here coming up underneath, goes this direction and this way, and then back up to come over top of that beam. Stair B is coming, let's see, yes, coming down this way. No, I'm sorry, coming down this way, over top of the Eiffel beam, and then it passes it. So the two stairs pass each other in this space. That's the only space we had to work with. And again, these stairs are 44 inches wide, code required, and 7-inch risers, 11-inch treads, which the existing ones are probably 9-inch treads and 8 or 9-inch risers. They're very much steeper. So it was quite a challenge to work that out. So we also did a series of renderings going up the stairs to show how the two stairs work. And here's where stair A coming up, again underneath the Eiffel steel, and then changes direction 90 degrees to miss this Eiffel beam, comes up over top of it and back up. After it comes above the Eiffel steel, this is the view looking back. This is stair B coming down next to stair A. It's in its tube enclosure with fire-rated glass, so you can actually see people coming and going from the observation level. And the people within stair B don't feel so completely contained. They can also see the Eiffel steel just through glass at this level. And then here's a image, not a very good one, but through the glass, looking toward the Eiffel steel, which is right here. At level 4, both stairs have returned to their quadrants, A and B. The elevator's continuous on up, and this drawing also shows some of the other locations for duct risers and electrical risers and so forth that had to be worked out. And finally, at level 5, the elevator ends. And so we have a one-stop lift provided here. So one will get off the elevator and come over and use this lift, which is in its own enclosure. And these stairs continue on up to 6P, which is the observation level. So that's where we're at with the design. The statue has its 125th anniversary actually tomorrow. And then the monument is going to be closed. The monument itself, not the island, is going to be closed to visitors for renovation. The project will run 1 year and be concluded next fall and dedicated on the anniversary, the 126th anniversary. 2012 is also the 40th anniversary of the World Heritage Convention, and I think it's very appropriate that the statue will be reopened in this banner year because the statue is one of the few World Heritage sites in our country. So thank you.